going to walk through the last of the regions of the brainstem, which is the midbrain. And so the midbrain is going to, I want to start with something that's not necessarily a brain tissue so much as is an endocrine tissue. Sitting at the very top, we have what's called the pineal gland. The pineal gland is where we make our melatonin. Right, so that sleepy hormone. This sleepy hormone can be influenced by two other major regions of the midbrain. So sitting right next to it, we have these two guys right here. These are the superior colliculi. And they are going to be sensitive to light reflexes. So when a bright light shows up, it plays a large role in that. It's going to react to things like blue light, right? So it can communicate to the pineal gland, say, hey, it's sunny out. Even if you're inside because you're using your phone, these make less melatonin. The other region, right, so these two below it are the inferior colliculi, which are going to be sound reflexes. So if you've ever heard a loud noise, I hope so, right? Bam, you're going to go look in the other direction, right? And so these will initiate a response to any auditory stimuli. Now, sitting down below it, we have kind of over here, we have what's called the substantia nigra. Substantia nigra is a black substance from all of its dopamine production. And that dopamine plays a very large role in motor initiation and regulation in other parts of the brain. So the substantia nigra is actually going to talk to different aspects of the cerebrum to regulate motor. So the substantia nigra is going to play a large role in that. Sitting next to it, we have our red nucleus. And the red nucleus is going to be like upper body muscle tone. And by muscle tone, I mean you have that structure of your muscle, right? If you have chiseled abs, you've got strong shoulders, right? You've got what your muscle looks like, right? When somebody loses muscle tone, the muscle it doesn't really have that contracted state anymore. And so they describe it as kind of more of a flaccid, kind of more flabby. And so you can actually see that it doesn't look quite like a shoulder would look. And so the red nucleus keeps that motor, the small background contractions so that your shoulders stay toned. We still see the reticular formation here. Okay. And the reticular formation actually developed here first. So it's going to be doing a lot of the heavy lifting here of essentially the motor aspect of our consciousness. So the medulla oblongata was playing a large role, and your heart's actually beating, you're actually breathing. The pons is playing more of the kind of coordination between the two, and again, a little bit more of the breathing. And then when we get up to the midbrain, it's the actual movement, right? You're keeping your head up, you're staying with it, okay? We do still have some white matter here. They're kind of hidden on the side here. But we have what's called the cerebral peduncles. And these are going to be essentially, they're most associated with motor. Okay. And they will send sensory information to the thalamus, because basically everything talks to the thalamus. But anyway, that gets us through all three regions of the brainstem. I hope this was helpful for you as you walk